Hi everyone, welcome to the channel. Let's solve a very famous problem, lowest common ancestor of a binary search tree. So given a binary search tree, find the lowest common ancestor of two given nodes in the BST. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in tree T that has both P and Q as descendant, where we allow a node to be descendant of itself as well. So this problem is very straightforward, and we recently also solved the lowest common ancestor of normal tree itself. That is little bit tricky, but binary search tree is very straightforward if you know basic traversals of the tree. So first of all, we should know the traversal of tree. So we can traverse a tree in two manners. One is DFS, depth first search manner, or another is BFS or level order traversal. This is breadth first search manner. In DFS itself, there are three different ways, like based on the how you are proceeding. So we have in order, pre-order and post order traversal. So here we will use the pre-order as that is best suits for us, so that we can keep comparing it and then take the decision based on where that is the P and Q lie with respect to the current node, which is root. So first of all, we start from this root node. We will compare. If root is null, then return there is basically there is no node, so no LCA. But in this problem, it is given that there always be a two nodes in the tree at least, and there must be P and Q are different nodes in the tree, and there will be a LCA. So we don't have too much worry about that condition, but next condition we need to check where does the P lie. P and Q is lie. If P lies left side of the current root node, the current node which we are processing, and Q lies right side of the current root, one case is this. Another case, Q can lie left side, Q lies the left side, and the P lies the right side. If these are the two cases, in that case current root is the LCA of these two nodes. So we will return the root as the answer. If it is not, then they can both can lie on the left side, like P and Q lies the left side of this node. How we will compare? Based on the value. As we know, binary search tree root, say all the node left subtree is less than or equal to the root value, and all the node of the right subtree is greater than or equal to the root value. So in that case, we just call the left subtree left subtree, search in the left subtree. If P and Q lies in the right side of the root, then we call the right subtree. So that is the only the approach. We need to put this all the condition in the if else if condition recursively, and you will get the solution. So you can pause the video, try to put this in your coding language by yourself first. So let's quickly start and run the code, write the code for that. So first condition, just put this, it is not needed, but I am just adding. So if root is null, just return root, there is no harm. If root dot val is greater than P dot val and root dot val is less, or better to put the equal as well, so that this will satisfy the condition it is mentioned over here. So the node of descendants of itself can be a LCA. So that is also the in second example. If you see here 2 and 4, we need to find out the LCA. So once we come to 2 and 4 is a descendant of 2, so 2, the current node P is itself the LCA of this. So here we will also put the less than equal to if Q dot val, or another case, the reverse case. So reverse case, if root dot val is greater than or equals to Q dot val and root dot val is less than or equals to P dot val. If it is these are the case, we will return root as the LCA node. Otherwise, we will check else if the condition like both lies on the left subtree. So if root dot val is greater than the P dot val and root dot val is greater than Q dot val. So which means both P and Q lies on the left subtree. So we will just call this same method by passing root dot left as the next root and p and q as it is. In another call we will return this else they both lies on the right subtree. So, we just call the same method with the right side. So, this is the code. Now, let us compile this code and see if it is working. So, this is how it is working and we are getting accepted answer. Let us submit this and it got accepted. So, how it is worked? So, first for p is equals to here 2 and q is equals to let us say 8. So, we compare current root 6. So, for 6 p lies on left side and the q lies on right side. So, 6 is the LCA of this tree. And for another example, if p is 2 and q is 4, then once we compare with 6 both lies on left side. So, we will call the left subtree method. Then we again root is 2. Now, we compare root equals to p, yes, and q lies on right side. So, these are lies on the both in the same or other side. So, we will return the true. So, 2 is the LCA of this tree. So, now what is the time and space complexity of this solution? So, as you can see here, we are doing kind of discarding every time half of the tree. So, the time complexity of this solution will be O of h. So, time complexity is O of h, where h is a height of our binary search tree, and the space complexity of this solution is O of n, the recursion stack, which is there can be a worst case when the tree is skewed, all the node will be, all the stack call will be called. So, that is how can we optimize either the time or space complexity. So, the time complexity we can't optimize as we have to process O of h node at least. So, for optimizing space complexity like we can do in O of 1, why just implementing this code in the iterative approach. So, in iterative approach what we need to do, we just wrap out the same code in the while loop, while root not equals to null, and now we use this all three condition and return it over here. So, this is what the condition. If we found the root, we will break instead, or you can return as well, or like return itself, and in the end also we need to return just dummy node, though the answer will always be written from here. And this condition is exactly same, we are calling this. So, instead of now calling this same method, we need to update our root by the, so this we will update root by root dot left, and similarly in this method call, in this here we update our root by root dot right. So, that is it. So, every time we will keep going left or right subtree based on this condition. If we found both p and q lies on the opposite sides of the current root, we will return that root as answer. So, let us submit this code directly and see if it everything works fine. Yeah, it got accepted. So, the time complexity is same as the previous solution O of h, and the space complexity is O of 1. So, if you want to write the VFS solution, we can also do that, but the time complexity and both space complexity in this code, like time complexity is same O of h, while the space complexity again O of n, as we have to store in the node in the O of q. So, you can try that VFS code by yourself. If you face any issues and difficulty, you can ask me in comment section. If you like the solution, hit the like button and subscribe to the channel. Also share in your friend circle. Thanks for watching.